Hi, you're welcome. Let's look at this question from JAMB 2017. The question says, the focal length of a concave mirror is 2 centimeters. If an object is placed 8 centimeters from it, the image is at, so we're trying to look for the length of the image from the mirror. So let's try and interpret this question proper. This is how we represent a concave mirror, right? This is a concave mirror. So they said the focal length is what? 2 centimeters. So this is a focal length. This is how we determine the focal length at what? 2.0 centimeter. What does a focal length mean? In layman's language, focal length means that the distance at which you place your object, at which you can see the full length of the object in the mirror, is the focal length of that mirror. So for example, now if I place this object in front of the mirror, I should be able to see the top of this object in the mirror and the bottom of the object full. So for those of you who have very long mirrors in your house, if you stand in front of it and you can only see half, it means you are standing at a line that is before the focal length. But if you stand at exactly the focal length of the mirror, you should be able to see the top of your head and the bottom of your feet or your toes, right? So that is what we mean by focal length. If I place this object here, I'm only going to see this part. If I place this, there is going to be space in the mirror. So the image tends to become smaller as I move it further away from the focal length. But if I move it closer, there's a point where I will not be able to see anything. I'll just be like in front of the mirror. So that's what focal length means. Now, in this question, it says the object is placed at what? Let's say this is the object is placed at 8 centimeter length from the mirror. The question is asking us at what length are we going to see the image at the back of the mirror, because usually in mirrors the images are caught behind the mirrors, right? So this is the length that we're looking for. And in mirrors and lenses, we represent the length of the object as u and the length of the image as v. The focal length is represented by f. And the formula given is what? The reciprocal of the focal length is equal to the summation of the reciprocal of the length of the object and the image. So this is what we have. 1 over f is equal to 1 over v plus 1 over u, right? So we already know what f is, we know what u is, so we can substitute 1 over f is equal to 1 over 2 is equal to 1 over v plus 1 over u. U is 8. So to get 1 over v, we can bring this here. So we have 1 over v is equal to 1 over 2 minus 1 over 8. We can look for the LCM to get this side. So the LCM here is clearly 8. So 8 divided by 2 is 4 times 1 is still 4. So we have minus 4. 8 divided by 8 is 1 times 1 is still 1. So it's equal to what? 3 over 8, which is equal to 1 over v. This implies that 1 over v is equal to 8, 3 over 8. So this is clearly the reciprocal of v. If we want to get v now, we take the reciprocal of the what? Of the other side, which is what? 8 over 3, right? So if you press your calculator, you're going to get 8 divided by 3 is what? 2.7 centimeters. So this is our answer. You check the options, you find that answer there. Now, what does this really mean? The length of the image is 8. The length of the object is 8. The length of the image is 2.7. It means the image was viewed at a distance closer to the mirror than the object is in front of the mirror. So This is what we have for this question. After doing this, be sure that you have gotten your mark for this question. If there is any confusion, you can ask me in the comment section, and I'll try to answer you. Thank you.